Yeah, hello all of you. So now in the last class you have done the design of tension members by using the welded connection. Now we'll go for the welded connections. Okay. So here is the problem. So tie of a roof truss consists of double angle ISA 100 by 75 by 10 mm with the long leg back to back connected on either side of a gusset plate of 8 mm by 6 mm fillet weld. Determine the strength of the weld. Fine. So now in the tie member is a roof truss. Roof truss means here you have the it may be a top card member or a bottom card member. The majorly to the double angle section we prefer it for the top card and the bottom card members. Okay. So that is the one thing. So here it is dimension double angle section. Next, placed longer leg back to back placed. That means longer leg is connected to the gusset plate. Okay. So next, back to back it is placed. Something like this. So here you have uh, the gusset plate. The longer edge is connected and the all shorter edge is outstanding. Next, uh, next gusset plate of 8 mm thick. So the gusset plate thickness is 8 mm by 6 mm fillet weld. Determine the strength of the tie. Now, when you find it out for strength, that means you need to find it out for the yielding, block shear, and the rupture. Okay, for all the three, you need to find it out. So, whichever is least in all the three parameters, that will be the strength of the tie member. And now we'll go for the ISA 100 by 75 by 10 mm. Area you already know it. So you can see this in the steel table. If you go in the steel table, you have it here 100 by 75. First, don't go with the page number because whatever the author you have, it is completely different from the whatever the author have downloaded here. It is different one. So first search for this one. Okay, back to back angle section. So here the back to back angle section for this figure you need to search. Then you need to search for 100 by 75. After that thickness will go here. The thickness is at the top. The thickness is 10. And the area is how much? Particular area is 33.00. And here, what is the area here? It is the unit of area is centimeter square. If it is in mm, it will become 3300 mm square. Fine. So next, if you go for this next page, here you want another one parameter is CXX. Okay. So that is in the next page. So here it is CXX. Here it is 100 by 75. The third row it is at 10 mm. So it is 3.19. It is in centimeters. So 31.9 mm. So you need to write down all these. Okay, after noting down all this and the tension capacity, first we'll find out the yielding. EGFI divided by gamma m naught. You will get this in the code book. So if it is in the page number, if you see in page number 32, you have the design strength due to the yielding of the cross section. TDG is equal to AGFI divided by gamma m naught. Use this equation and find out what is the TDG value, that is tension capacity. Okay. So now if you find out this, you will get the 750,000 is nothing but it will convert Newton to kilonewtons. Fy is in Newton per mm square. Fy is an assumption 250. Newton per mm square is the unit. So that will become 750 kilonewton when you divide it by 1000. So as you know, we are going for the welded connection. So if you are finding it for the double angle section, it is a two angles you have it, right? So now so whatever the area you have, TDG you have got, that has to be divided by two. Each angle, what is the load carrying capacity of each angle? So that you are finding it out here. So if you divide it by two, that will be 375 kilonewtons. Okay. So as we have question says we need to weld it. So here you have you need to find out the strength of the weld. One thing I just wanted to tell you is you can use this method or you can use the whatever the method we have done in the second module. Taking the section at the top, one section at the top, and you can find it out what is L1. And same thing, you can substitute that the L1 is equal to L2. First, we'll find out in terms of LW, then we'll find it out by you taking the section at at the one end, and we'll find it out, or one top we'll find it out. Okay, so that you can do it. So, or else we can go with this method also. I'll tell you this method that whatever we have done, that method also you can follow. Okay, so now at the top and at the bottom, we'll divide these two. And one thing here, wherever you have the outstanding leg, there you need to weld it completely. Fine. So now this I will take it as L1. Top I will take this as L1, and at the bottom I will take this as L2. Okay. So strength of the weld equation, we'll find it out here, and you will end up with this value in terms of L1. Same thing, same strength of the weld equation in terms of L2, you will get it here. Fine. This you are familiar with this, right? The equation you are familiar with the strength of the weld equation. It is not in the code book. You need to by heart. Next, distributing the weld in each way that CG of weld coincides with that of the angle section. That means whatever the weld we are doing, so that should coincide with the CG point. That means C. So if you finding it out here, so now this this I will take it as P1 now. Okay, so this P dash, this I will take it as P1 now. Fine. So now here what happens here is, if I take this as a P1, and if I wanted to find out, okay, if I take this as a P1, and if you P1 and P dash, that you will have to assume these two values. Okay, so if I take this as a P1, I will take this as a P dash. Fine. So this you need to remember. Okay, so next what we will do is, here we'll find out for the uh, equating on the both the sides. That means we are taking the section on the bottom, and P1 into 100, P dash into 31.9 as the XX value, that you will get it here. Fine. Next, what is P1? P1 is nothing but L1, strength of the, this is P1. Okay, strength of the weld at the L1 length. So this is P1. P1 is equal to 803.3 L1. Substitute here into 100. So you got the P dash. What is P dash? What is the strength of the weld of the one particular weld? It is P75. Substitute here. Right? So that you will get L1 as so much, substitute, you will get it as 150. Right? Now we'll go for P1. Okay. So we don't know what is P1 and all, right? So we got the L1 here. So what is P1 here? 803.3 L1. Now we got to know what is L1. Substitute it. Okay. 803.3 into L1 is 150. Divide it by 1000 because it is in newtons. 803.3 is in newtons. So we are converting to kilonewtons so that we will get this one. So we got to know now what is P1 now. Okay. That is force or the strength at the weld L1. Okay, top. At the top it is P1. Now P1 and P2. Bottom it is P2. P1 plus P2, that will become strength at the middle, P dash. Okay, so now we will equate this one. Okay, so now P dash is equal to, if you put the P1 on that side, what happens? P dash is minus P1. This way, if you move it that side, it will minus P1, it will become. So what is P2? P2 is equal to, what is P2? 803.3 L2. Right, write down. So 803.3 into L2 is equal to P dash minus P1. Fine. Did you understand this? So now we'll take this one. So what is L2? If you put this in the other side, what happens? 803.3 will be in the denominator. Fine. So now you got to know now this, right? So you will get substituted, you will get this. What is P dash? P dash is nothing but 375 into 10 raised to 3. It will convert into kilonewtons. Sorry, newtons. So minus 120.49. So divided by 803.3. Fine. So now here you will get 320 mm. Right? Next, this is about the L1 and L2. So L2 you should get maximum because at the wherever you have the outstanding leg, there you need to weld it uh, length. Length should be higher in the outstanding leg. Wherever you have the outstanding leg, which side you have or top or bottom, however you place that side, it will be length will be higher. That is the one of the check you need to remember. So that is about it. So we got to know what is L1 and L2. Now we'll find out for what is the strength due to rupture. Okay, so this is as usual as your this one uh, bolted connection, but here you need to remember is here you have if you go in the steel code book, it is in page number 33. TDN is equal to single angle. Whatever you are seeing is for single angle. TDN is equal to 0.9 ANC FU. You have this equation, right? So this equation is multiplied by 2 because whatever the equation given in the code book is for single angle. We need to make it for double angle by multiplying it by 2. Fine. Now beta value. To find out beta, we want W, BS and LC. I'll tell you what is LC. So here you see the figure now. So here it is BS and W. This is for welding, this is for bolting. Now we are welding it. So W is equal to BS. Okay, so now W is nothing but outstanding leg. So substitute it here. Okay, so what is W? What is outstanding leg? 75 mm. W is 75 mm. Next T is 10 mm. LC is whatever the length of welding we are doing, higher length. So 320 is the higher one, right? Here. So that one you need to write it here. Next, beta value. Substitute everything over here in the beta equation. Beta equation is in your code book here. Okay, 1.9, everything, FU, FY, everything is substituted, you will get better. You will get something around 1.31. Okay, so here you have one more parameter. Here if you see it here B, uh, FU divided, FU gamma M naught divided by FI gamma M1. You need to check this. So you will get something around 1.44. And it is zero point 0.7. Always beta value should be greater than 0.7 and lesser than this value. Like that you need to design. Okay. So then whatever value we have got is lesser than 1.44 and greater than zero point 0.7 and it is safe for us beta value. Next ANC is equal to A minus T divided by 2 into T. As I told you earlier, so now if you want to find it out in angle section like this, okay, so here you have an angle section. So here, if you want to find it out the area for this particular length, what is this 100, right? So this is 75. 75 is from here till here. So that means, so whatever the 100 by thickness is 10 mm. So you will end up till here, right? So now we got to know what is the one side. But what about other side from 75 till here? It will be the another one. So what happens to this area? This we are taking it twice. So we need to multiply it by, sorry, subtract it by t divided by 2 on the either side. Okay, here I will take half, here I will take half. So what happens now here? Here we are deducting half on the other side so that it will become okay for on the all the others, all the sides, right? So now we'll go for the next one is AGO. AGO. and A is nothing but whatever the connecting leg length is there. 100 is the side which is connected. C indicates connecting, O indicates outstanding. Connecting is 100, outstanding is 75. Substitute everything, you will get these two answers. Next, you need to multiply by 2 because it is a double angle section. Now you will get answer as 977.5 kilonewtons. Fine. Next we'll go for check for block shear. AVG, ATJ. Okay, AVN, ATN. Gross and net. Gross and net is will be equal because here we are finding it for the welded connection. Gross and net when it will come into picture is when you are finding it for bolted connection. What happens? Your plate, what you will do, you will drill a hole and the whole of the area is not present over there. There is some loss in the area, but so that you will get net area over there. But what happens to welding? The whole area will be there, will not cut anything. The in any area or some area is not lost, it will remain same of the gross area, so it will be equal. Okay, so how do you find it out? It is 320 into 10. How many sides we are welding? Two sides, right? Net, because we are taking 320 on the, assuming it as in on the either side, 320 into 10, you will get this. ATG is nothing but 10 into 100, 100 complete 100 into 10. Okay, so that you will get it as this one. Next, substitute everything and you need to multiply it by 2 for the equation. So this equation you will get it in the code book in page number 30 here. It is over here. So TDB is equal to AVG divided by. So which you need to find it out for both, and whichever is less in these two, that you need to calculate, take it into account. Next, so if you catch up, substitute it, the least one is this one, 2269.96. 2269.96 is for block shear. Now we need to find it out strength for whole section, right? So this is the one thing you need to remember. Next, will if you find it out for rupture, how much? 277.5. That is the one more one. One more is how much? 750. Okay. So least of all these three is 750. That will be the strength of the welded tension member. Okay. So this is about the analysis of the double angle section by using the welded joint. Okay, so this is about the this will continue in the next class. Thank you.